Under the ice of this moon, there is thought to be more water than in every ocean on Earth combined. In 2022, a spacecraft measured how thick that ice is. The answer was not what anybody hoped. This is Cosmion. Point it at any question in the universe, and it will show you the answer, whether you can bear it or not. Europa is a shade smaller than our own moon. If you set the two of them side by side, you would genuinely struggle to tell which was which on size alone. For most of human history, that is all anyone thought it was. Another rock going round another planet, one of dozens out there, and not obviously more interesting than any of the rest. Then the pictures came back, and the surface was wrong. Our moon is covered in craters because a dead world keeps every scar it has ever taken and has no way of losing them. Europa does not look like that at all. Its surface is smooth and pale and almost unmarked. Instead of craters, it is crossed everywhere by long reddish-brown bands that run for hundreds of kilometers and cut straight over the top of each other in every direction. Those bands are not impact scars, because impacts do not draw lines. They are cracks, and something down there has been opening them. That matters more than it sounds, because a surface only stays that clean by being remade over and over, and ice only remakes itself when there is something soft enough to move underneath it. So the interesting question about Europa stopped being what its surface looked like and became what was sitting underneath it. And the answer that fits everything we can measure from out here is water. Not a pocket of it trapped somewhere, and not a slush mixed through the rock, but a global saltwater ocean wrapped right the way around the moon and held in under the ice. And this is the part that quietly rearranged the entire search for life beyond Earth. That ocean is thought to hold twice as much water as every ocean on this planet put together, which is a sentence worth slowing down for, because it is easy to hear it as a statistic and completely miss what it does to the picture. Everything alive that we have ever found anywhere needs liquid water to stay that way. And until fairly recently, the honest position was that Earth had more or less cornered the supply. Europa turns that straight around, because it means the largest body of liquid water we have any evidence for anywhere at all is not on this planet. It is out at Jupiter, sitting under a lid, on a moon small enough that you could hide it inside our own and still have room left over. That is why Europa has sat at the very top of the target list for something like 30 years, not because anybody has seen anything living there, and not because any serious person is claiming that they have, but for the simple and rather unglamorous reason that if you are going to spend a fortune looking for life, you look where the water is. The difficulty is that an ocean under a lid is an extraordinarily awkward thing to check on. You cannot photograph it, and you cannot sample it from orbit, and every single thing we think we know about it we worked out indirectly from the outside, by watching the way the ice above it moves and cracks and refreezes. Which leaves one question sitting quietly underneath all of the others, and for 3 decades nobody could give you a straight answer to it. How thick is the lid? You would reasonably assume that we knew. We had been photographing Europa since the 1970s. We had a spacecraft working in the Jupiter system for most of the 90s, and the ocean underneath had been argued about in print for an entire generation of scientists. We did not know, and we were not close to knowing. The estimates that had been published put the ice at anywhere from under a kilometer to tens of kilometers thick, and it is worth being clear about what a range like that actually represents. That is not a measurement with an error bar attached to it. That is every possibility still sitting on the table at once, with nothing available to choose between them. The gap between those two answers was never a technical detail either, because the two of them describe completely different worlds. A thin shell would mean an ocean still in contact with the outside, cracking open and freezing shut, and letting material pass through in both directions. A thick shell would mean an ocean shut away underneath something we would have no realistic way of reaching. Both were genuinely possible, and both had serious people behind them. The trouble is that you cannot see through ice from orbit, and you very obviously cannot drill it from several 100 million kilometers away. What you can do instead is read the temperature, because ice sitting close to liquid water is warmer than ice sitting near the surface, and if you can take that temperature at several depths at once, then the thickness of the shell falls out of the physics. Doing that needs an instrument sensitive enough to feel heat rising up through solid ice, and it needs the spacecraft carrying it to get genuinely close. On the 29th of September 2022, NASA's Juno spacecraft came within 360 kilometers of Europa's frozen surface, which is a shorter distance than London to Newcastle, only pointed straight down. At that range, its microwave radiometer could read the temperature of the ice at several different depths, and across that single pass, it gathered data covering roughly half of the entire moon. One flyby, one instrument, and the first time anybody had ever managed to look underneath the surface of Europa rather than at it. Then the data came home, and after 30 years of shrugging, that enormous range finally collapsed down into an actual number. In the region that Juno looked at, the ice averages about 29 kilometers thick. Now, 29 kilometers does not sound like very much when the thing you are describing is an entire moon. And to be fair about it, measured against Europa itself, that shell really is thin, roughly the proportion of the skin on an apple. The problem is that we are not the size of a moon. We are the ones who would have to get through it. The deepest hole that human beings have ever drilled is in the far north of Russia, and it took roughly 20 years of work to reach 12,262 meters. The rock down at the bottom became too hot and too soft to keep drilling through, which is why that hole has stood as the record since 1989. Europa's ice is more than twice that deep again, and it is not conveniently located in Russia. It is on a moon at the far end of the solar system, sitting inside Jupiter's radiation, at temperatures cold enough that the ice behaves less like ice and rather more like rock. But the depth on its own is not really the finding that matters here, and if the film stopped at the number, it would be missing the point entirely. What matters is what that depth does to everything else. An ocean is not automatically somewhere that things can live, because water by itself is not enough and never has been. It needs chemistry going on inside it, and one of the things it needs is oxygen. On Europa, the oxygen is not down in the ocean, where it would be useful. It is up on the surface, locked in the ice, at the top of all of this, which means it has to get down there somehow. And that is precisely where the mood changed, because NASA's own conclusion from this measurement is that a shell of that thickness implies a longer route for oxygen and nutrients to travel from the surface down to the ocean underneath. Not an impossible route, and nobody involved has said impossible. A longer one. But longer, when you are talking about 29 kilometers of solid ice, starts to matter enormously. There was one obvious way out of that problem, and the same study went and closed it. Look at any picture of Europa, and the first thing you notice is that the whole place is covered in cracks. So it is entirely reasonable to assume those cracks are the route down, running from the surface and opening a path for material to work its way towards the water. The team modeled exactly that, and what they found was that the features are too small and too shallow to be a significant pathway. I want to be careful at this point, because this is exactly where a film like this one normally overreaches and starts telling you something the evidence will not carry. Nobody has proved that Europa's ocean is cut off from the surface. NASA has not said that, and neither am I going to. What this study says is that the route down is longer than we had hoped, and that the cracks are unlikely to be the shortcut, and both of those are carefully hedged statements drawn from one instrument, on one pass, over one region of one moon. The scientists involved are the first people to point that out. Steve Levin, who is Juno's project scientist, put the limits on his own result about as plainly as anyone could. The 29-kilometer figure describes the cold, hard outer layer of the shell. And if there is a warmer and softer layer underneath it, which he says is entirely possible, then the true total is thicker still. But if that ice holds even a modest amount of dissolved salt, which several models expect it to, then his own estimate comes back down by about 5 kilometers. So the honest summary is not that Europa is dead, and it is not that the search is over. It is that we finally have a real number instead of a shrug, that the number came in bigger than the optimists were hoping for, and that it could still move in either direction once somebody measures it properly. Scott Bolton, who runs the Juno mission, described the thickness of that shell and the question of whether it has cracks running through it as part of a complex puzzle for working out whether Europa could support life at all. Part of the puzzle, in other words, and not the answer to it, all of which leaves us needing something considerably more thorough than a single flyby. There is something more thorough, and it is already in flight. Europa Clipper left Earth on the 14th of October 2024, and with its solar arrays open, it spans about 30 meters, which NASA points out is roughly the length of a basketball court. That is not for show either, because out at Jupiter the sunlight is so weak by the time it arrives that a spacecraft needs wings on that scale simply to keep its instruments powered and running. On board, it carries 9 separate science instruments, along with a 10th experiment that uses the radio link back to Earth to feel the pull of the moon as the spacecraft goes past. The obvious thing to do with a machine like that is to put it into orbit around Europa and study the moon properly, month after month, until it finally gives up an answer. Clipper will not be doing that, and it is worth understanding why, because the reason shapes the entire mission. It cannot orbit Europa, because Europa sits deep inside Jupiter's radiation, and anything parked in that environment is being steadily destroyed the whole time it is there. JPL describes Clipper as a radiation-tolerant spacecraft, which is engineering language for built to take a beating. And the beating is real enough that the electronics are housed inside a part of the spacecraft that NASA simply refers to as the vault. So the mission was designed around the damage rather than pretending it away. Instead of orbiting Europa, Clipper orbits Jupiter on a long, looping path that carries it out into the safer dark and then brings it back in again. And on each return, it crosses Europa fast and close, takes everything it can, and gets out before the dose adds up. It will do that 49 separate times. That is also why every one of those 9 instruments runs on every single pass, all of them at the same time, because there is simply no opportunity to take turns. There is no coming back next week to check something that looked odd. Each approach amounts to a few hours of usable science bought with months of looping through empty space, and whatever is not captured on the way through is not captured at all. It is a genuinely strange mission when you sit with it for a minute. We built the machine that answers the biggest question we have about that ocean. Then the ocean's own surroundings turned out to be so hostile that the machine has to steal its answers in short bursts, retreating every single time in order to survive long enough to take the next one. There is one more cost to all of this that tends not to get mentioned, and that is time. Clipper travels 2.9 billion kilometers to get where it is going, and that is not because Jupiter happens to be that far away, but because the route is nothing like a straight line. It is a series of long loops that borrow speed from other planets on the way past, and taking that route costs the better part of 6 years. It arrives in April 2030, and the European Space Agency's JUICE spacecraft, which is heading for the same system on its own path, gets there the year after that. So the answer does exist, and it is coming. It is simply not here yet. Which raises a question you might not have thought to ask, which is where that spacecraft actually is at this moment. The answer is that it is nowhere near as far away as you would expect. On the 3rd of December 2026, Europa Clipper comes home. It swings back in past Earth and takes a gravity assist from our own planet, which is the trick of borrowing a little of Earth's motion in the passing to throw a spacecraft faster and further than its own fuel could ever manage on its own. That flyby is the thing that sends it the rest of the way to Jupiter. It is worth being clear about what that date actually is, because it is not a launch, and it is not a landing, and it will not look like much. It is the last time this machine will ever be anywhere near the world that built it. After December, it is outbound for good, and everything it does from that point onwards happens somewhere that none of us are going to follow it to. And when it finally arrives in 2030, it starts working on the question this entire film has just spent 20 minutes failing to answer from several 100 million kilometers away. How thick is that ice really, everywhere? And not just along one strip that one spacecraft happened to fly over. Is there any route down through it? Is there chemistry in that water worth the name? We had a shrug for 30 years, and then in 2022, we got one number from one pass, and the number came back bigger than we hoped. From 2030, we get another 49 goes at it. Nothing about Europa changed on the day Juno measured that ice, and the ocean did not get any smaller. The only thing that changed is our understanding of how far away it genuinely is, and that distance was never really the one measured in kilometers across space. It is the one measured downwards, from a surface we can already photograph in detail, to water that no one has ever seen. 29 kilometers of it. And the machine that goes to close that gap leaves us in December. Thank you for watching. If you want to be here when Clipper makes that pass, subscribe, because we will be covering it when it happens. Next time we are staying at Jupiter and moving one moon inwards to a world that is doing the exact opposite of this one. No ice and no ocean underneath it. Hundreds of active volcanoes instead, and a surface that tears itself up and remakes itself faster tthan anywhere else in the solar system. Next time, Io.